If you are in this video, it's because you want to know how to use Fusion and how to import a model from Fusion to Ansys and how to analyze in Ansys a model. So we're gonna start the tutorial. I hope before starting, I want to say that I'm not a professional and I'm just a student who learned how to use Ansys for model. I just want to tell that I'm a new person on this model, also using Ansys, using CFD, so I have no clue of many things. It's just a simple tutorial to how to understand Ansys and how to transfer a model from Fusion to Ansys, in which format or type you should export it and how to do it. So we are gonna start from the tutorial. In my case, I'm gonna use a airfoil to because it's a simple model and you can see the coefficient of drag and the lift and all that things, the pressure. So we are gonna come to this website. I'm gonna let it on the description. It's called airfoil tools. So I'm gonna let it on the description and we are gonna analyze this profile. This wing is the NACA 63A010. So we are gonna come into the website and we are gonna come to where it puts date file. We are gonna copy all this. We are gonna Control C, copy all, and we are gonna open a node blocks, and we are gonna paste it. Once we have it, all the code here, we come to File, Save As, and we put the name. For example, NACA 63 A010 dot data. Sorry, dot data. It has to be saved as data, because if not, you are not gonna be able to put it into Fusion. Once we have it all, we can close everything and we can come to Fusion. Okay, once in Fusion, we have to start a new model, and we will start a sketch. Create a sketch, and we will you will have to create an airfoil. You will have to have this complement of Fusion. It's not included in the normal listen. So you come to utilities, complements, Fusion App Store. Once it's open, we search airfoil, and in my case, I have this one. So you will click it, download it, and once it's downloaded, you will come to Fusion. You will have to close it and to open again. So you restart it. Once you restart it, in create a sketch, it should appear airfoil sketch from file. If you had this this complemental, it's not necessary to do this process. So we are gonna make a line, for example, from here. I don't use this point because if you then rotate the profile, one point is gonna be stuck on here, so the model is gonna not be identical to the airfoil. So we are gonna trace a line of 100 millimeters, and we are gonna enter to sketch options, and we are gonna select the line and types of lines. We are gonna select construction, the first option, this icon here. Once we select it, we come to the airfoil sketch, create airfoil sketch from file, click it, and be sure that this is on blue text. You click the line and accept. You select your file. Once you have it, if you can appreciate here, the model is not closed at all. This is because you will now have to do a little step that I'm gonna tell you. And sketch, and we are gonna rotate it a little bit to see better the lift. We select all. For example, 5 grades. This is gonna generate downforce. And once we have it, we will come here right click, edit sketch, we can erase this line, and we will come here, and instead of finishing the lines like this would generate problems at the point of meshing with Ansys. So we are gonna erase it, and we are just gonna make a straight line on here to here, just a straight line. This is for not generating so little places on the wing that could make Ansys broke. Because if you use model too little, for example, I'm using millimeters. So if you come here, you will see that the distance between these two lines is very little. So if you come here, this line will be even littler. So be careful with that. Don't use that because about the process of meshing, Ansys will not let you. So once we have it like this, and we have made that straight line, we come here, we select our wingspan of our wing. For example, I'm gonna put 75 per side, 25 millimeters. Okay, and now once we have it, we come to file. Once we have our finished model, we come to file, export, we put our name, wing analysis, Ansys, and we save it as step file, step export. We make sure that it's exported, and we come to workbench, Ansys workbench. Okay, now in Ansys, we will come to fluid flow, these options, and we will select fluent. We will drag here, and we will double click on geometry, double click. This will initialize the design modeler where we can import our file. We come to file, import, and select our model. Generate. If you see that like this thunder, like this little icon, you will have to click on generate. Okay, now once we have the wing, we are gonna click on this plus sign, and we are gonna make sure that there is only one solid. If there are many solids, we will have to click them all to select, and once, for example, select many things on the tree outline, and once we have it, we will right click, and there will be an option that it's called fusion part, or connect all parts, or join all parts, or create a new part. You will click it, and it will stack it. This option will stack all solids in just one and create a new part. It's like join all the parts. Okay, now once you have it, make sure that on the solid appears this icon, like a cube icon. If it appears like just a face, an icon of a face of a cube, it's just a surface. So this Ansys will erase it because it's not like a model, and you will have to make it bigger, that face, or stitch it on Fusion. So we can close here. We come to units and millimeters. I do this because our model is 70 millimeters of long, so it's too little. I will not use meters because it's not that big, our model, to use meters. Okay, now once we have changed our units and we stacked our models, we will come to tools, enclosure, and we will generate it. Okay, if you can see here, it will create a domain for our wind to pass, for our air. We want this model to be bigger, no? So we will change it. Okay, first of all, we are gonna change this face that is in the axle X positive, because this is the axle of X. This face, if we click on X positive, it will bring us to this face. So we come here and we will put 100 millimeters, or even 150 millimeters to make it more realistic. Now we are gonna make it on X negative, X negative, that is this face of here, x negative, it doesn't appear, but if you click on the axle, you continue, it will appear. So x negative, we will put 60 millimeters. Maybe it's too little, yeah. Let's put 100 millimeters. And in the set that is this face of here, positive, we will put 70 millimeters of tall. Sorry, I clicked the wrong button. And the set positive, that is this face of here, we will place 50 millimeters. Okay, this is our domain created. Now we will come to create and boolean. What is the boolean gonna do? Boolean is gonna suppress the solid on the inside of our model, and it's gonna create a cavity where the air is gonna pass. So the cavity is where the air is gonna, well, just it's not where the air is gonna pass, it's where the solid is gonna be. So we come to boolean operation, we change it to subtract target bodies, we come to our solid, not our solid, just the solid of outside, the enclosure one. We apply, and the tool body is gonna be our body, in my case, my wing. I'm gonna apply it and generate. The model should look like this. If you had any type of problem, try with another mesh, and if not, try different adjustments like I do with the rear wing of here, that maybe is an angle that is too little, or there are surfaces on your body. So you come here, tool, well, before doing anything, if your model is symmetric, if you come to here and look it and it's symmetrical, like in my case, that is a wing, you can cut the model on two, and that it will be the same because it's symmetric, and you can just analyze one part because it's not necessary to analyze both because it's the same. This will make the calculations easier and faster for the computer, and then you will have to multiply by 2 the results. So you come to tools, symmetry, and looking on the top of the wing, you come on the top of your model, you will have to look to the planes, you come to symmetry plane, select, and you will have to select the one that is just one line of dots. For example, this one will not be the correct one, that crosses all the model. For example, this one, the green line is crossing the model. This one is crossing like this. This one is crossing the model in half. We apply it and we generate it. And now we are finished with our geometry. We can close the design modeler and come to mesh. Double click mesh. Okay. Our mesh is now rendered. Okay, we will right click mesh. First of all, this is our model, and we are gonna right click on mesh on the tree outline. We are gonna select mesh, right click, and generate mesh. Okay, in my case, it has given me an error that put me that is not the acceptable quality for meshing our project. So in this case, we are gonna change we click mesh, we come to element size, and we will change it to try, for example, 50 millimeters. We are gonna make the squares bigger. So we come here, right click, generate mesh, and we're gonna see. In theory, it should complete our mesh. Let's wait, and we will have our mesh here finished. If you can see, it has formed a cavity here. Okay, now you can make many options here to make the mesh better on quality. For example, you can select all the faces. You come here, face selection, you select all the faces of your model. In my case, it's just a wing. And you will right click and insert sizing, the first option. Once we have select sizing, we will generate mesh, and it should generate a mesh more accurate to our model. Okay, maybe your model is just smaller, or is a entire plane, for example. So maybe you cannot select all the faces of your model. But with the last option, it should be great. Now, once we have our mesh finished, we are gonna select all the faces where we are gonna program on the setup from via our wind, or for via our solids. So we are gonna click first the symmetry face, we click it, right click, and we create named section. We call it symmetry. Now we select this face, the face that is looking, the face that is looking at the wing here. If you see where the face where you want the air to come. For example, in my case, I want the air to come to this. So I select it, right click, create name section, and we call inlet. That is where the air is gonna go in through our wing. Now we come to the part, to the other face, to the part of pack, and we select it, create name section, we call it outlet. It's where the air is gonna leave our model. Now, once we have done this, we are gonna select the rest of the faces, the floor, and the rest of the faces. With the shift to select many faces, we right click, create name section, and we're gonna call it wall. Now we have to select the wing. For make it easier, we can activate wireframe. We click wireframe, and now we will see our wing. We can select geometry, solid, and we will see the wing. So now you will have to come to selection mode, box select, select mesh, and now select all the wing. You select it, and now you right click, create name section, and you put wing. If your model, for example, is a plane, you can name it plane. If it's a car, you can name it car. The name of your object. You can get out of your single select and of the wireframe, and this will be done. So you can close mesh, you can close it, and you will come to setup. Before entering setup, and while it's meshing closing, you will come to setup, and you will right click on mesh, and you will click update, because this is the sign that you have to update to transfer the information into setup. Update. Once the information is transferred, we'll double click on setup, and it should be appearing this little setting window. On this window, we don't have to touch many things. We just click solve options, double precision, and solve process. I recommend 2 or 3. This depending on your local machine. So I normally use 2 or 3. I'm gonna use in this case 3, but I will recommend you to use 2. We start. Okay, now once we are here, it will appear this little game behavior changes. Okay, once we are here, it will appear this little window. We click OK, and now we will come into general. We double click general, and we will select pressure based, velocity formulation absolute, and time steady. In general, you can look at a scale display. Well, I will use display to select the faces that we want to see on here. It's not obligatory, it's just to see the model. For example, I can remove all the faces and let only wing display, and it's only gonna display my wing. So now we are gonna come into models, double click, and we are gonna select viscous est omega, k omega SST. This is the most accurate one for what we want to do for airflows. We can also select K epsilon, but it's not as accurate. K omega and SST is like the fusion of both. So we click on K omega SST production limiter. We OK. And now we come to materials. We will change the material to air. Once we have changed our material to air, we will come to boundary conditions. Double click, and we will select inlet. We will make sure that it's velocity inlet, and we edit. We click on edit. Now on this little window, we will select the velocity or meters per second of our air. In my case, my object, I want it to be at 80 kilometers per hour. So it would be 22 meters per second. This calculation is just select your speed in, for example, kilometers per hour, and then you will have to multiply it, or if you want to pass it into meters per second, you will have to divide it into 3.6. You will have the formula here. Apply. You click apply and close. Okay, now you will have to make sure that on outlet is pressure outlet, symmetry is symmetry. On type, you will have to select outlet, pressure outlet if it's not placed from default. On symmetry, symmetry, and wall and wing on wall, and the rest on wall. Interior solid also interior. And now we are gonna come into the solution one, and we are gonna come to initialization. We will change the mode. We will change the mode from initialization of hybrid initialization to a standard one. We click it, and we change this this option that is called compute from, that is start from inlet, and we will click on initialize. You can change also here the velocity of the air, the turbulence, I'm gonna let it as it comes from default. We will click on initialize. We will wait, and now we double click on run calculation. Okay, before running our calculation, you will have to change the number of iterations. That is, this is the times that the computer is gonna make our process. In my case, I'm gonna put, for example, 250, because it's a model that is not that big. It's a little model and it's just simple. If you, for example, had a car and you want to have a fast analyze, maybe you should put 100 process. But if you have a car and you want so detailed and so accurate data, you will make more calculations. These depend of your interests and what is your objectives. Before clicking on calculate, we will come to monitors, residuals. We will click on this plus sign, residuals, double click residuals, and we will deactivate all these options. On the check convergence, we will deactivate it. We will click OK, and we will come again to run calculation, and calculate. And now we will wait this calculation to finish. It will be a graphic that will display us all the data that is calculating. After waiting some time, this icon would appear on the window. So we click on OK. And now we can close this. This would mean that our results are ready to be analyzed. So the solution has been checked and just remains to see the results. So we double click on results. We waited to open the window. And now we would see our model charging. Here it is. Okay, now we are want to see the analyzing. So the first of all, we are gonna create a plane here on where the model is cutted. So we come to, wait, sorry, we come to location, we select plane, okay, and then we will have to select the where is place. We select all domains, method, and we will want to select the face that is cutting our model. So in my case is the ZX plane, that is this face. This will change depending of your model and where it's placed. In my case is the Z axle and the X axle that are cutting on this one. So it ZX and apply. And this gray little window should appear and your model should appear also with the model. Okay, now here we are gonna put many things. For example, we can place contour. We come to contour, that is the second option, contour. Okay, and then here we will select all domains, location, we select our plane to appear here, and we will select variable. Here you can change everything. For example, in my case, we are see the pressure of where from the wing, on which places of the wing there is more pressure. And now we are gonna select a number of contours. If this number is bigger, there will be more contour. For example, if I place 11, you can see that is so simplified and it's just a simple contour. But if you put, for example, 200, it will be smoother. So here you can analyze the pressure, the pressure of the wing and where is the pressure distributing. You can now deactivate the plane for a better analyze. So you can see here now the wing and how the pressure affects around the wing. So on this case, the biggest point of pressure is on the angle of start of the wing, and this is a low pressure place of the wing. Now we are gonna see the streamlines where the wing passes through the wing. Before using the streamlines, you can also put this pressure on instead of the plain one on the same wing. On the wing you apply it, and the contour of the pressure will apply to all the wing. So here you can see the pressure of all the model, of all your model, because my model is just a wing, but maybe in your case is a whole car, and you want to see where are the places where more with most pressure, with less, and where the downforce is being generated or where the lift is generated. So now we can disable the contour and we come here to streamlines. Streamline, we select it, we click it, and okay. It will appear these options. We select 3D streamline, start from, and in this case you have to select. For example, I'm gonna select inlet, the phase where the air is coming. Number of points, I will highly recommend you to put a big number like 1000. And we are gonna see the variable of velocity, direction, forward and backward, to see if there are any type of vortex that are generated on the process. We apply it, and we will see a big problem, that is that we cannot see anything because we had put it the air to come from the inlet, to start from inlet. We can here analyze, but it's not the most visual thing. So we can change the start from to plane 1, apply it, and now it would just start one line of wind here, and now we could see how the wind affects to our wing. In this case, the speed of the wing is not that fast, so maybe there are not any type of vortex that we could see here that they are forming, but then you can analyze all the type of things that you want. You can also, for more analyze precision, you can upgrade this number. So apply 2000 and it will be more accurate. As you can see here, there is no air. The air is dividing here, like where you can see many different things here. You can also, for example, see vectors. You can see volumes. You can, well, but we are gonna go with the calculation of the drag coefficient and the lift coefficient. You will come to calculators on here. We will click and we will come to function calculator. Double click and we will select function force for calculating the force of the coefficient. We will select our wing on location, and now we are gonna change our directions. To calculate the drag, we are gonna look first for the axle that is crossing all this line, this straight line. That will be the x1. So we are gonna calculate, and we will see that when the air is coming from here, all this one is generating this force. This would be our drag of the drag of our wing, that is 0.064. This is the drag that the wing is generating. Now let's see the downforce or the lift coefficient that our wing is generating. We will change it to the Z1 and we generate. This is gonna give us probably a negative number because, well, it's gonna give us a negative number because it's not any type of force generating into the axle, into Z axle, because the force is going down. It's down force probably, so it's gonna give us a negative number. 0.62, this is the force of lift, but it's not generating lift, it's generating downforce. So this is how you calculate all the things. I haven't explained too much on the result. You can see many type of things and many type of calculations, but this is the most simplest things that you can do on Ansys, and it's so useful for making wings, for making your model, to know how much downforce do you need or how much lift do you have to have, how your model like tricks the air during all the process, the speed of the air, where it generates vortex, how much drag that it generates. So this is the tutorial. I hope you learn. I will have to say that I'm not a professional, I'm just a student, and I'm just learning a little bit how to use this one. In many times I had errors and things, so if you have any type of suggestion or any type of ideas to make this process better, I will highly recommend you to put it on the comment section, to not also help me to also help all the people that is looking at this video. And thank you so much for staying this time. And I hope you like it and you learn.